rest. Wanna stay in bed, an object in motion. Wanna get ahead.
Today I'm going to teach you some very simple demonstrations and tricks that you can do at home, and all of these tricks revolve around the concept of inertia. And in physics, inertia is a property that all matter has. It's a tendency to stay at rest or to stay in motion. So an object at rest wants to stay at rest unless an outside force changes it, and an object in motion wants to stay in motion forever at the same velocity unless an outside force causes it to change. So you might be wondering, how is it that when I push something across a desk that it ends up coming to a stop? If objects in motion want to stay in motion, shouldn't it just keep going forever? Well, the answer is it would do that, but there is an outside force that's bringing it to a stop, and that force is friction. So in the real world, it's really hard to observe objects continuing their motion forever because there's always friction to slow things down. But it is really easy to see that objects do tend to want to stay at rest. So let's take a look at all of our demos, and you can learn something really cool along the way. The first trick has a very simple setup. Just put an index card on top of a cup and then place a coin on top of the index card. So I'm using a penny. And so the card goes flying, but the penny falls into the cup. So why does that happen? It's because of inertia. The penny was an object at rest. It wants to stay at rest. And because I applied a force to the card, it accelerates in this direction. But the penny, having no force applied to it, remains at rest and then just falls in due to gravity. For my next trick, I have a cup filled with rocks sitting on top of this black tablecloth, and that's resting on top of this desk here. So what I'm going to do is pull this cloth quickly and hope that I don't spill this, because if I do, I'm going to be cleaning up a lot of rocks. Here we go. On 3, 2, 1. Okay, so what happened here? The trick is to pull quickly, because if you pull too slow, what happens is this tablecloth has friction that would pull the cup with it. So pulling it slow is not a good idea. You're introducing that force of friction. Pulling fast allows you to overcome that friction just by pulling quickly enough for it to be negligible. And then filling the cup with rocks increases its mass. And remember, the more mass you have, the more inertia the object has. So by giving this a lot of inertia, I'm encouraging it to stay at rest, because that's what objects at rest want to do. If I tried this with an empty cup, likely there would not be enough mass, not enough inertia, and the whole cup would accelerate with the tablecloth. For this next trick, I have a stack of dominoes here. There's 15 of them, which is more than I usually would try. It's pretty unstable. And you want to make sure there's a little bit of lip at the bottom. So make sure one of them is sticking out, just so you have something to grip with your fingers. And I'm going to grab it and pull as quickly as I can and hope for the best. 3, 2, 1. Oh, it survived. Okay, so why didn't it fall over? Well, again, it comes down to inertia, right? If I take the bottom domino and pull quickly, I'm applying a force to that domino, but there was no force applied to these dominoes, which means they're objects at rest and they want to stay at rest because of their inertia. And so they stay, and then gravity brings them down. So why can't this work if I pull this bottom one slower? Well, if I pull it too slow, now it's going to drag the rest of the dominoes with it, and it won't work. So the key again is a very fast force, so that friction becomes a negligible force and doesn't mess everything up. So this one is a variation of the one we just did with dominoes, but instead of pulling an object from the bottom, I'm going to apply a force and push it. And it's just going to demonstrate that it works either way, whether it's a push or a pull. So stack up a bunch of boxes, take a meter stick or other long object, and just give it a little flick like you're playing pool. And look at that. And you could continue this all the way down. Oh, dropped it. What happened here? Again, I applied a force that was fast enough to make friction not really a significant force. If I push that bottom one too slowly, it's just going to drag everything with it. But if you push it fast, then inertia just makes these objects that are at rest want to stay at rest, and so they fall down. Remember, inertia doesn't just tell us that an object at rest wants to remain at rest, but it also tells us that objects in motion want to remain in motion at a constant velocity. So let's watch how that works in a car crash. And so it might have looked like the car threw this person forward with a force, and it might feel like that in a real car accident, but there is no force that's pushing you forward. What really happened was the car itself feels the force, and so it accelerates to a stop, but the person who is already in motion just wants to remain in motion. So if you're not wearing your seatbelt, of course, you feel like you're being thrown forward, but your body is just continuing in the direction it was already moving due to your inertia. So this one is my favorite demonstration of inertia. Basically, you just need a container, and the narrower its opening, the better, because it makes it more dramatic. And then you get a ring of some sort. So this one's just made out of wood. And then on top of it, you can put a pen or a marker. And then you just reach in and you quickly grab the side of the ring and pull it rapidly in that direction and hope that this marker falls in. So how does this work? Remember, the only thing that had a force applied to it was this ring, and the marker that was sitting on top of it did not. So it doesn't accelerate, its inertia compels it to stay at rest, which is exactly what it does, but then gravity makes it fall down and go into the opening. Now I got lucky this time because I did put a little spin on it and it just happened to land perfectly into the hole, but the goal is to get it to fall straight down without the spin. And there you have it. There's a handful of simple tricks that you can try at home, and maybe you can impress your friends with them. So the lesson of the day is objects at rest want to stay at rest, objects in motion want to stay in motion, because anything with mass has inertia. And more importantly, the more mass an object has, the greater its inertia. So things that really are compelled to stay at rest or stay in a constant state of motion tend to have more mass. And objects with lower mass are much easier to accelerate. It doesn't take much outside force to cause something small or light to accelerate, but something that's really, really massive is going to take a significant amount of force because it has way more inertia to overcome.